The experiment which we are going to discuss now is stability analysis of linear systems. So we are going to use a MATLAB software in order to obtain the waveform of a linear system. It can be we can be use a Bode plot or a root locus plot in order to find the stability of that particular transfer function. So as far as this experiment is concerned, two problems are being provided here. One should be solved using Bode plot and another should be solved using the root locus plot. So you people are advised to solve these questions individually to find the value of k. For the first question, you need to find the value of k so that you can substitute in the MATLAB instead of that k value, so that you can you can put a small program, so you can run the program and you will find out the waveform. So then you're going to check with the theoretical as well as the practical waveform which you have received. Similarly, for the root locus, you have to calculate for the second problem, find the value of k, and that you have to substitute. So for now, we have discovered the value of k for the first one is to be 1, and for second one is to be 52. So we are going to substitute these two values in MATLAB, and we are going to find the waveform of the two equations. So let me go to the MATLAB. So first what you have to do is you just go to the MATLAB. You have to select new script. A new script box will be opened where you have to type the small program. So I'm going to type the small program here. Like yes is equal to transfer function, which is mentioned as yes, and g, the whole formula which is given here. You can see g of s is equal to, I'm going to copy this and paste it for your reference for now. This is the one which you are going to put here. So you could see g of s is equal to k s square 1 plus 0.2 s 1 plus 0.2 s. So this is the formula which is going to, or this is the equation for which you're going to find the waveform. So the same thing I have typed here. So you could clearly see k value is 1, which we have calculated from the equation theoretically. So 1 into s square. So I'm putting s into s for the numerator bar, and for the denominator I'm typing the whole thing here. So I hope you don't have any doubts in this. So you type completely over there. So now we have this Bode G, which is to be given in order to calculate the Bode plot, and axis equal. That's it. You have to type these 4 lines and you have to run the program. So okay, this is untitled. I'll use this, for which I have already saved. So you'll receive a output waveform graph. So now you have to check whether you have received the exact output graph when you solve the problem theoretically. So you will be receiving the exact one. So this is how we have to check for the theoretical as well as for the practical one. So this is for simple Bode plot. Similarly, for root locus, we have to do the same procedure. So I'll just open which I have done earlier. For the root locus, we go for the root locus again. So you could see the formula which I have listed here. Again, I'll take the formula which we have given for solving. So again, for k, we have found out the value to be 52, substitute instead of 52, and we are putting the same equation. We are expanding and we are like typing it here. For root locus, we just typed r locus. So that's it. These 4 lines, and you're going to run. Yes. So this is the output waveform which you have received. So you have to check for the theoretical as well as for the practical one. So both of them will be equal. You have to solve the problem theoretically and you have to draw the graph theoretically, and then you can put the small program inside the MATLAB and you can take the output easily. So this is for the 6th experiment, that is stability analysis experiment.